Elemental Lewis structures. So today, that's what we'll be talking about. So Lewis dot structures are an easy, simplified representation of an atom. They're made up of two components, which would be the element symbol and the dots representing valence electrons. So, or VE. So how to draw a Lewis dot structure. So first, what we're going to do is write the symbol from the periodic table, right? So we have Ne from the periodic table would be neon. So we put neon, right? Before we start adding any of the dots, let me explain to you what they are. So these right here are valence electrons, right? So we'll just put VE for valence electrons. And we have to put them in a specific order, or else, it just doesn't really, work or fall together. So we start off with 1 here, and we go clockwise. So we go 1, then we go to 2 here, and then 3, then 4, and then we start back again at 5, 6, 7, 8, so on. So I have an easy way to tell. So we have column 1, column 2, and then column 13, 14, 15, 16, 17, 18. Right? So if you look here in the periodic table, right, we have 1A, 2A, 3A, 4A, 5A, 6A, and so on up to 8A. Right? These numbers represent how many valence electrons, right? So in column 1, all of the elements in column 1, hydrogen, lithium, sodium, potassium, rubidium, they all have 1 valence electron, which would be at the top because it starts at 1. 2, you would have 2. So beryllium, magnesium, calcium, strontium, all of these guys have 2. Same thing happens here, right? 3, so boron 3, 4, 5, 6, 7, all the way up to 8, with the exception of helium. Helium has 2 up here. We'll explain why in just a minute. So if we look at neon, neon is right here, column 8, column 18, which is also 8A for the valence electrons. It has 8. So we go 1, 2, 3, 4, 5, 6, 7, 8. That's how you would draw that. So for example, let's say we want to do let's go ahead and let's do phosphorus, right? So we're doing phosphorus here. We got phosphorus. So we got the symbol for phosphorus. We go look at our chart. Where's phosphorus at? Right here. So we count, right? So it's 1, 2, 3, 4, 5. So phosphorus is going to have 5. So we write it down. We have 1, 2, 3, 4, right? So now we go back around. 5. This would be for phosphorus. Now, I know that in the last video that we had made, we had left something out for our covalent Lewis dot. So I suggest you go watch those, if you are already on those. But Vesper, this is kind of a way. It's kind of like a key, right? So the Vesper theory assumes that each atom in a covalent molecule will achieve a geometry that minimizes the repulsion between the electrons in valence shell of that atom. So there's no direct connection between a molecule formula and its molecular geometry. However, Lewis dot structures can help us to predict shapes. So basically, right, when you're doing covalent Lewis dot notes, right? So example, for the one we did, CO2, we have this written down or drawn out, right? So Vesper helps us kind of name those shapes, right? So if we go look what's similar to that, we can tell here, this one looks like the CO2, and that would be called linear. If we had anything else that, they're just names to pretty much describe its geometry, to describe its shape. It has angles on how far apart the electrons are, and that's pretty much it for the Vesper stuff. So I hope you enjoyed this video, guys. Please leave a thumbs up and subscribe. Thank you.